Greetings, masters. Welcome to first streaming in CloudCompare. Today we're going to try to show you how to align point clouds that were scanned with revopoint mini. Well, let's get started. So here we have CloudCompare. And here's the files. I will start by just dropping the files here and checking all the point clouds that I've captured. Okay, so one of the tools here, one of the first ideas to do this is to select the meshes and use the transform rotate to put them more or less facing the top view. So you set it on top view and you use the right mouse button to move, and the left to rotate the image around, in this case the point cloud. So if you need to adjust the screen, you just hit pause and you use the right mouse button to do translate. To resume editing, you just click on the pause again, and it's just like you roughly set it here, and you use a check mark and it's done. Let's do the same here with this one. So let's select this one. You can select it here or here. Now, if you click on Shift, you will lock the rotation only to this axis. So with Shift, you can just fine-tune this area. One of the tricks I usually do, since there's no grid marks, unfortunately, is to use the edges of the screen to roughly align it. So I'll just drop it here, use the Shift key, and roughly align it like this. So I would do this for all the parts. Here another translate, so roughly just vertically, more or less. Shift, rotate it. Okay, here it is, and another one. So this is the one. Translate again, move it, rotate it, and so on. So once you have everything more or less aligned, you can use the other views to make sure they're more aligned with this. So you can select it again, translate and rotate, and the same thing applies here to the Shift key. If you press the Shift key, it will only rotate on the axis facing you. Okay, so I've done this process already, and basically what you want to end up is something like this. So top view, left view, and front view. So these are not aligned, but it doesn't matter. So this is just to give us a rough estimate of how the point clouds are. In this case, there's a couple of here that are not usable. I have issues. As you can see, the scan was done. I scribbled the faces of the part to try to get some detail that will help us during the point cloud registration. And you can see the points of blutac that I added in order to create features for the scanner to align and be able to capture it. Because this is a featureless part, very plain parts are hard to scan. I've also set it on a textured surface, as you can see here, in order to increase the chances of a good scan. So basically just moved the part and then did a couple of scans. So with this we will try to choose the best scans, ideally the ones that don't have issues, and I can see some issues with this one. This one, for example, the holes are closed and there's a misregistration here, so this one we will not use. And this one has very few points here, not a lot of information. This one is a good one. This one's another one. And I can try, let me see, this one is more complete than that one here. So we don't need the other ones, but I'll keep them on the timeline. I will just tick them off so they don't show. Okay, so now we have the two scans we want to align, for example, here. One of the things, the first things we should do is we should use the segment tool to remove, or at least separate, the parts of the point cloud that we do not want. So how do you do this? So let's check the front face, and this is where aligning everything to a set view is helpful, because it allows you to easily change views using the tools. So we choose the segment, and the way the segment works is you can just trace either around what you want to erase, and in this case you click with the left click, and to stop the tool you right click. And then you have two ways of doing it. Either you segment in, and that will select this part and remove everything outside of this part, or you select out, which is what we want to do. The thing happened here was we are not on the correct mesh, so I'll just cancel. This is the mesh I want to use, or you can also just select the two meshes if you want to work on the two meshes at the same time. Okay, I just used shift here, it's not what I wanted to do. Okay, so let's delete this label. Okay, so selecting the mesh, left view, segment, and let's do the selection that we want, right click, and in this case we want to segment in. Everything else will be removed. And at this moment we haven't changed anything in our point cloud, it's just in memory. So let's continue. So once you select the first segment out or segment in, it automatically goes into pause. You can use space also to toggle between pause and play. If you do play, you can now, for example, select this area and do segment out. So this one is clean. So we could also remove these parts if we want, but I'll leave this for the next part. Once you choose confirm, you will split it into parts, or you can just simply select delete and it will delete the hidden points. In this case I will just use the confirm just to show you how it works, and as you can see it creates a new area. One of the things of CloudCompare is it usually creates new point clouds or new selections of the point cloud, but it cannot and it does not have undo feature. Basically, because point cloud calculation is kind of intensive, so it's cheaper to just create a new point cloud than to go back and undo edit. So for that reason, you just have to plan things a little bit ahead, and eventually you can, if you want to do something that you don't know if it will kill your point cloud, you can use the clone entities to create a new clone of the selected entity, and you can do the operation on that entity instead. Okay, so we don't want the remaining, we just want the segmented here, and we will do the same for this one. So segment, let's go into the side view. If you want to move around and you can't, don't forget to put it on pause so that you can zoom, track, and restart. So in this case, we just want to select this, and we want to segment it in. In this case, I'll just do confirm and delete because I don't really want the other points. And as you can see, it did not create the remaining and the segmented. That information is gone. If you need this information again, you would either clone the point cloud, or you will have to import the point cloud again. With that said, we already have our 2 point clouds that we want to align. So to align, the simplest way, there's a couple of ways to do it. You can either use point picking and matching. That usually works, but ideally for this you should have a general, even if it's a low resolution capture of your object, but it has to be some overlaps, otherwise the program will not be able to fine-tune it. And then there's the manual way. We will just try to use it manually here. So with my point cloud selected, I'm going to use again translate rotate, and I'm just gonna drag this here, gonna hit shift to lock it to the view rotation so I don't mess around with rotation, and I will just align by eye more or less. Every time I need to move or change, I can just hit spacebar, and then I'm not moving the part, but I'm moving the view. I can hit spacebar again to enter into translation rotation mode. As you can see, if you forget to hit shift, it will screw the part, but you can always cancel and it will not apply the rotations that you did. So translate rotate, shift key, rotate it, right click, drag, position the part, space, drag the screen, space again, drag the part, and try to get it as close as possible. So yeah, I think this is pretty well. Shift again and just trying to find the right inclination here, so it looks like something like this, and it is probably somewhere around here. So we can go to the top view and check if the parts are aligned vertically. So they're not. We'll just move this in order to have the holes aligned. You can see there. space, and we are out of transform, and we can move the part to check the other area, space again, shift, and we want to not just move, we want to slightly rotate this to match the other one. So it's mostly okay, wrong. Forgot to turn off okay, so space to turn off so you can move, and right click to roll around. So now we have mostly it's a match here. Okay, with this done, we can select can do OK, and I will just go and duplicate these two to work on the next phase of the work. So I'll just hide everything I don't want to use except the two new point clouds. There's a slight misalignment here. What we'll try to do is we'll try to see if the program can use the fine alignment and if it works. Okay, so we'll select the tool and we'll select finally register. So here you have to define which is the face that will be stable. So if you remember, we aligned the faces to the top. Ideally you align one that is where you want it and you use that as a reference. One of the good practices is to just rename the face. So you double click it and you make app series reference, and the others can be whatever name they are. So with the reference selected, we will try to finally register, and in this case the final overlap, you should use a value around 80, 50, something like that. We'll try with 70. You can just try it like this, so the reference is reference and to be aligned is clone. Let's see what the program does. Okay, so I would say that the program, the alignment is not bad, but it's not in the right place, and that's normal because you don't have enough references. So what he ended up doing was the major areas, he ended up aligning them and considering that the bottom surface is the same as the top one. In this case it's not too bad for us because that means it's centered already, so we will use that to our advantage. So I'll just select the registered point cloud and I will move it down, only down somewhere to here, but it should be pretty well aligned now. There you go. Okay, so with these two I can just select these and I'm going to clone these entities again. Just turn these off. And now I'm going to select the two of them and I'm going to merge them into just a single entity. This merge process is one that is it does not have a return, so it does not create a new mesh. So ideally you should always remember to clone the point clouds before you start the new one. No, that's too many clones. So select the two and merge multiple clouds. Do you want to generate a scalar field with the original cloud index? So a scalar field is It's like kind of like the point cloud RGB, but usually has something to do with gradient. It usually uses gradients. I'm not sure what it is, to be honest. In this case, what happens if we select the scalar field? It will create a different color for each, and it will separate those by two colors. It's useful to have it with that scalar field because you can select by color, and that way select the merged mesh. So as you can see, it created red and the blue, which is the two meshes that we aligned. And so did we lost the RGB color? Well, no. The color and all the fields that we create are stored here in colors, so we can change to RGB again. Another thing that's usually helpful to use is to create a scalar field. For example, when you import data that does not have any type of RGB color or any type of shading, you can use this tool here, which is the ambient occlusion point cloud, that basically calculates a shadow map for the point cloud. I recommend you to just drop this to around 64 to be faster to calculate. And if you use this only in northern hemisphere, it usually uses the top view, the Z view, which is interesting to see the parts of the point cloud that are facing down. So let's just try it. As you can see, it creates a grayscale-ish kind of illumination. So it attributes given to the light source coming from the top color to each of the points. So you can check and see how it is working. If you zoom out, you can kind of check how the quality of your mesh will be just from the point clouds. There's also you can also edit the not edit, you can also increase or decrease the default point size. That will make it more dense, the point cloud. This is useful especially when you are trying to evaluate the quality of the point cloud, quality of the mesh, the potential mesh at close points, because when you do a close-up, if you are on the minimum point size, it will start to get sparse. So you can increase it just to have a better view of how it is. Also, it's also good to use this to find out the stray points. We can do further cleaning of this part by selecting the segment again, and for example removing these nibs that are here. So let's try to do this. So I'll just go into this view, put it on pause so I can zoom, move, edit, and I will just try to select the outliers here. So I know these are parts that I don't want, so I'll just select them, and I will right click to accept, and I want to segment these parts out. So at this moment I'm on segmentation pause, so I'll just move, and in this section I can see there's this left view is not properly aligned. We can align it better. Let's do that now. So I'll just delete those, and I will go to move translate to see if I can align this a little bit better. So I'll go to top, and I'll use the side of the screen. Oops, nope, should have used shift. So let's go back. So rotation translation, right click to translate, shift to lock the rotation to the z-axis, and let's try to approximate this edge. Let's, okay, it looks okay. I think we can just shift and try to rotate just a little bit more, something like this. It's probably good. And let's do accept. As you can see, the outbox alignment also changed, and now it is the same as the part. So this means the part is well better aligned. Here you can see it's up here and down there. So what we can do is use the rotate translate again, shift and right click. So I'll just use the right click, drop it close to the edge of the screen, and I'll use shift and left click to rotate on the view axis here. So okay, and let's continue with the segmentation. So let's try to segment the parts that we don't want on this point cloud. So this is the blutac that I use to add the information. So I'll just select everything I don't want here. This should be okay. Right click to stop selection and segment out. Unpause and let's remove some more of these points that we don't want. There you go. So segment out. You can also remove these ones. Pause, select here, but these could be probably automatically removed with the noise removal that we'll see in a second. So segment out, let's confirm and delete hidden points, and there we go. So there's a couple of blutac points there that we can probably just remove. There's a couple more here, and a good way to do that is to try to align the view best you can so that you can grab the most points and then segment again. So I'll just remove these ones here, and I'll just go here and segment out. So since it's paused, I will move the view again and approximate the best angle I can use to remove the most parts. I will unpause, select, right click and left click to confirm, right click, segment out. Let's do just a quick check to see if we can remove any other things here, but it's pretty much okay. Something weird there, but I'm not gonna touch it. So yeah, pretty much our point cloud is good. So I'll just trash the points that I don't want. And what I will do next is to just do a quick meshing to see how the part is. So for the meshing, we use here the Poisson surface reconstruction. What I usually do with revopoint scans. For preview I just use 8, which is faster, and for final mesh I either use 9, max at 10. Usually above that it will just take too long and you won't see any real results from it. Again, a couple of things that are important here. Output density as scalar field. This is very important. The output density as scalar field will allow you to create histogram that will have the kind of color mapping that will allow you to select by colors and remove automatically or select the parts that you don't want to be on the mesh, the parts that are interpolated and created by the Poisson surface reconstruction. The advanced tab, so usually I just always keep output density as scalar fields. The advanced, I usually use 3. The boundaries don't differ much. Newman usually creates more concave surfaces, this one creates more convex, and the 3 just ends the boundary freely, kind of that. So but I don't know much information about these settings. I just know this one is the one that gives me best results. So if anyone knows more information, send me a link so I can learn about it. Samples per node. I usually use 1, and the points per weight I usually use between 0 and 1. Mostly 0.5 or 0.25. Now these are settings for the scans with revopoint mini. Other scans in other point clouds you may need to have different settings, but in this case this works well. So the threads are the number of CPU that you have. In this case I have 24 available threads, so I'll use them all. And this I really don't know what to do, what it does. So we'll keep it like this, and we'll just do 8 octree depth test, and this will be quite fast. Now it reconstructed the mesh, but it's still showing the point cloud over the mesh, so we have to hide that to check our mesh. So here we have, this is our reconstructed part, and these reliefs here, which were caused by the blutac, can be removed further here with the segmentation manually, or you can do the mesh and then drop it on mesh mixer and reduce it, or you can just use it as is, depending on what you want to do with it. So for example, one of the things that we can see here with the scalar field, as you can check here, this area does not have much information. We can compare with the point cloud. It's pretty much empty here. So this is being interpolated here. If you want watertight mesh, you would just use it as is, and you can print it because this is a watertight mesh. But if you want something for referencing on another CAD program, ideally you should then do remove these parts that were interpolated by the algorithm. And the way you do that is with the scalar field. So like I said before, you have the display range here, and what you can do is select as you can see, it will start to disappear. You can select can clip the bottom part. So around here is the green is basically what is information still, and from here down is just the imagination of the program, let's say like that. So for reverse engineering, I will just clip it here and use it like this. But this is just a visualization, so you don't have the part clipped like this yet. If you want to do this, you basically select it here, and then you have this tool which is filter by points value, which will automatically use the values in this display range, and then you can just do an export. Split will just remove it from the part, export will create a new part. As you can see, it created a new part and also updated the scalar field. But here we go. We can just go back again to the point cloud. So I'll just delete, I'll keep these meshes. I will go back to this point cloud, and what I'm going to try to do is just see how the noise removal works in this point cloud. Maybe it can remove those parts. So in tools, clean noise filter, this sphere is in millimeters, is in the units of your scanner in this case. So we're working in millimeters, so I'll just try to remove points that are around 1 millimeter and remove isolated points, which is points that are not in this mesh. So let's calculate, and it creates a new one. So let's do one thing here, which is to go into the top view, select the old, and compare one with the other. As you can see, the new one with noise removal, it's much cleaner, and it will result in a better mesh. One way we can check, compare one to the other, is to select the new one, use the move translate, put it to the right, and then we can look at the old one again. So the stray points that it had on the side are basically removed. This will create a better mesh. Okay, so I'm happy with this, so I'll just select it and do a final mesh with 9 octary depth. Everything else as is. And we'll see the result. So let's just disconnect. Let's just hide. And there you go. So this is a final mesh. You can see, if you want to check the mesh without the scalar field applied, or if you want to see the RGB, which can be converted to texture, you can go to colors and just check the part that you want. So this could be converted to texture. It can also help the fine register. We didn't use that, but we could have used it. If you, I'm not going to do this, but let's see, select two parts, select final register. In research, there's a use displayed scalar field values as weights. This helps in aligning the meshes, because it will not only compare the points, but it also try to compare the colors of the points. And if you have a texture, in this case, if you capture the RGB, it will help with the alignment. So another thing that you could change is the scalar field. We have talked about it. RGB is the texture, and if you select none, it will show you just the mesh. As you can see, there was some markings down here that got captured also. This is the ejection pins on the molding process, and vaguely there's a table here with the years and stuff like that. So the quality of the scan is very good for a scanner on this price point. 101K price point is a very good scanner. Okay, so last step would be to just export this into a mesh. Then we can open it on another program. You can open, for example, on Mesh Mixer and repair and clean up these parts of the mesh. Maybe we can try this. So file, save will act on the selected part, and just mesh reference as an object. So I'll just start here Mesh Mixer quickly. This is a bit off the scope, but I'll just import what I exported. Here you go, in Mesh Mixer. And for example, let's say we want to clean up these parts here. There's two ways. You can just select it, delete, and fill in, or you can use the sculpt tools to try to delete these parts. So for example, if you use the sculpt tool, you can use, for example, robust smooth, change the size, and just rub it like this to remove basically that bump. The other way is you can do select. You can select the part that you want to remove, and you can go here and create erase and fill. What it will do, depending on the idea you do, if you use the flat remeshed, it will just use a flat plane. Flat minimal will try to use a less amount of polygons, and smooth MCV will just try to recreate the surface that you deleted. So you do accept, and so let's get out X, ask. So that's the difference. In here you have still the bump that was created. Here it just removed the problems that we had. So let's just do it again here. Select. So I want to decrease the size. I want to remove this bump here, this one, that one, and the other. And just go edit, erase and fill. You can also hit F, accept, escape, and that didn't work very well there, but this is a good time to go to sculpt, increase the size, and just smooth out the bumps. Pretty much our part is clean up. Just smooth out here a bit more. Yeah, still have this problem here. The thing is, if we had imported this area, as you can see, you can also see the difference where there's information like here, and where there's no information, where the program basically tried to interpolate the mesh, there's a lower resolution. So we would just export this now and open it on a CAD program if you want to reverse engineer it, or if we just want to print it like this, we would just drop it. Of course, I would remove the bits that I don't need here and the blemishes that I don't want, and I would then just go and import this into a CAD program to do the reverse engineering. And that's probably what I will do next time. I may do a reverse engineering video for showing how you drop this on, for example, Fusion 360, and how do you use it as a reference to build your part. But for today, I think this is it. I hope it helps anybody. See you soon.